All right, and here we go with the final team presentation from the Georgia Tech, Intel, UNICEF Code for Good for disaster relief and recovery. And this is Team Data Mule. You want to go ahead and start off?
Yeah. My name is Andrew Price. I'm a grad student here at Georgia Tech, and this is Team Data Mule. One of the things that we were working on is improving the communication capabilities of embedded systems during a disaster scenario. So basically what we wanted to do is we wanted to make a system where every node can be collecting data, but only a few of them are connected to the internet at any given time. So what the system does is it will check around and see if it has any neighbors. If it has neighbors, then they will share whatever data it is that they've collected, and then whenever someone makes it back to an area with network access, then it will proceed to upload that information to the cloud. And then once you've uploaded something, then that data will be propagated back and say, hey, this stuff's already been sent, you don't need to worry about this anymore, so they can sort of clear their area. I think this is useful in a lot of situations where you're going to have distributed workers, you're going to have groups of people coming and going, and you're going to have lots of different sort of collection activities happening. So this needs to all be managed automatically. All of these phases have been tested at some level, except for the automatic component. We're still working through a few bugs with getting the system up and running autonomously with no human input. But if you shepherd it along, you can run an Arduino sketch that records your data. It'll save that to a file on the file system of the embedded system. And then when it comes into contact with one of its buddies, they will synchronize, and then the one that's connected to the network will proceed to upload that. So we've got all those working. We just need to make sure that it works hands-off. So there's not really a whole lot to show. We can show you 3 boards sitting on the table, but you know, there's not a whole lot of use for that, I suppose. One of the other projects that we worked on was actually trying to improve the capabilities of the embedded board itself, the Galileo board, in terms of being able to run Git for using file diffs and that sort of thing. So I'm going to hand it off to one of our other team members to talk about it.
So as we were thinking about the architecture for setting the backbone for the communication channel, we realized that we need to come up with an approach where as the number of nodes grow, you need to start exchanging data between all the nodes. And you also don't want to lose data, like if a node is lost, you still want to retain the data. So what we thought was we want a distributed data collection, and whenever the nodes come close to each other, they exchange data and everyone gets the same copy. And one software which immediately came to mind was using Git. So it can easily resolve your merge conflicts, and then it can even easily give you a hash, order the data properly, and you can even run some secure protocols on top of it so that you can maintain the security aspect. So for that aspect, we initially tried running Git on the Yocto distribution which we had. We hit some roadblocks, so we decided to fork off and still see whether we can get this working. We finally managed to get a Debian distribution running on the board, and then we set up a Git repository. Then we tried out a Python wrapper on top of it, so that if you have other applications which are using Python, you can just easily plug in the backend which is using Git for the data storage aspect, and build on top of it, and you finally get the whole system running.
Excellent. So if you had 12 more hours, what would you try to get done?
The main thing is we'd like to make all of this work automatically without any human input. We'd also like to collect real data rather than just some of this spoof data that we've collected. So add some hardware into the loop and just a lot of testing. Testing.
Merge with the other groups.
Let's merge with the other groups.
Merge
They've done.
Yeah. Excellent. Thank you very much.
One thing I should have mentioned, we did wrap a lot of this functionality into an Arduino API. So the intention was for other groups to be able to call this functionality, and then so you could transfer the data that you've recorded. So that's another thing we'd work on in the next 12 hours.
Yeah, actually, we would have managed that just by 3 functions. One that basically opens a data collecting session, one that writes a new piece of data, and one that closes and sends the data session. So it would have been very simple for other groups to use. I heard that they were having a lot of troubles trying to get all the network stuff set up. And if we had our stuff working, it would have made their lives a lot easier.
So hopefully coming to a GitHub repo near you before long, so that everybody else can make use of that in the future. Great. Thank you very much.